Hello everyone, I welcome you back to Benju's Education. And our today's topic of discussion is the very basic questions of inequalities for GMAT students. And in this video, we'll be discussing questions related to the DS part. Okay, so if you're like completely new to the data sufficiency inequalities, and let's suppose you're preparing it for the first time, then this video is going to be very important for you. So I have taken up like around 12 very basic questions, okay, which are based on like the basic concepts of inequalities. Like for example, if you know that a into b is greater than 0, then the conclusion to that is either they both are positive or they both are negative, right? Similarly, if a into b is less than 0, then one of them is negative, one of them is positive. Now, how do you use these concepts in the question? That is exactly what we'll be doing. Okay, so this is like the very what basically I have done in this video is I have picked up very basic questions, okay, and no difficult questions we'll be doing in this video. But yes, this video is really very important if you're doing inequalities for the first time, right? Because inequalities with data sufficiency is like one of the trickiest topics for GMAT preparation. All right, okay, let's move on to the first question now. So pause the video and try the question, please. Okay, let's see how we can solve this one. So the question is A equal to 8? You have statement A, which is A square is equal to 8. You have statement B, which says A is equal to even. So let's start with statement number 1. That is, we have A square is equal to 8A. Now, what generally people do in this question is they cancel one A on both the sides. They say, okay, let's cancel A, and that will simply give us A is equal to 8. But this is incorrect. Okay, this is incorrect. Try to understand the reason for this. Now, the first thing is there is no such thing as cancellation of terms on either side of equality or on either sides of inequality. Right? You can't just cancel terms. That's not how the way math works. If you want to remove the same term on both sides of equality or on the both sides of inequality, then what you do is you basically divide. So if you have a square is equal to 8a, so if you want to remove a from both the sides, what you will do is you will divide both sides by a. So this will basically give you a is equal to it. This is basically what you are supposed to do if you want to remove a from both the sides, right? But now there is a problem in this. Now this is applicable, this division part, this division by a is applicable only when a is not equal to 0. This division part is only applicable when a is not equal to 0. Like for example, if a is equal to 0, then anything divided by 0 is not defined. Even if you do 0 by 0, that is also not defined, right? So in this case, we can't divide by a, or basically we can't cancel both sides with a. We can't do that. Okay. So what we will be doing in this case is we will be subtracting 8a on both the sides. So this will become a square minus 8a, which is equal to 0. So this is like a into a minus 8, which is equal to 0, which will give us a is equal to 0 or a is equal to it, which will give us a is equal to 0 or a is equal to it. So do we have a conclusive answer? No, we don't have a conclusive answer, right? So if we talk about D, A, B, C, E, so in this case, we have A which goes out, D which also goes out. Okay. Now the second one, it says that A is even. So if I talk about even numbers, like I have like infinite number of even numbers. I can have like 2, 4, 6, 8, 10, 12. I can have minus 2, minus 4, minus 6, minus 8. Like there are like a lot of even numbers that I have. So it may happen that A is equal to 8. In that case, the answer to the given question will become yes. It may happen that A is not equal to 8 and it's another even number. In that case, my answer becomes no. So again, do I have a conclusive answer? No, I don't have a conclusive answer from statement 2 also, which means B also goes out. Now let's combine the two. So the conclusion for both the statements that I have is, for the first one, the conclusion is A is equal to 0 or 8, and the second one is A is equal to even. So what's the common part from A0 or A8 and A even? The common part to this is A is equal to 8. Now if you think so that A is equal to 8 is the only common part, then again you are wrong. Then again you are wrong. Remember that 0 is also an even number. Remember that 0 is also an even number. 0 is neither positive nor negative, understood, but 0 is an even number. So if A is even from one statement and A is equal to 0 or A is equal to 8 from another statement, then again you again have two possibilities. That is, you can have A is equal to 0 or you can have A is equal to 8. You still have two possibilities. So that means C also goes out and my answer simply becomes E. My answer again simply becomes E. So two concepts, two important concepts that you have learned in this question. One is this cancellation part, like it's not effectively cancellation, it's like division or multiplication on both sides. So be careful with that. And second is when you talk about even numbers, 0 is also an even number. All right, let's move on to question number 2. Pause the video and try this question, please. Okay. Is x is equal to y? First one is px is equal to py. So you have px is equal to py. Now in case of px is equal to py, don't fall in for the trap of cancelling p on both the sides. Again, please don't do that, right? Because if you want to remove p from both the sides, you will effectively be dividing both sides by p. You will effectively be dividing both sides by p. Now again, I do not know whether p is positive or negative, right? I do not know that. Okay, so I can't effectively cancel both sides by p. So what I'll be doing is I'll simply be doing px minus py is equal to 0, basically subtracting both sides by p. This is what I will be doing. So this will give me p into x minus y is equal to 0, which will again give me two conclusions. One is p is equal to 0 or x is equal to y, which will give me two conclusions: p is equal to 0 or x is equal to y. Or I can combine both the conclusions and at the same point of time I can have p is equal to 0 as well as x is equal to y. Right, these will be my three conclusions. So the question is x is equal to y? Now if in case p is equal to 0, if in case p is equal to 0, you take any value of x and y, it doesn't matter, because 0 multiplied by any number will always give you 0. So let's suppose if you took x to be 10 and y to be 12, 0 into 10 is again 0, 0 into 12 is again 0. So you don't have to worry about it, right? So if p is equal to 0, then whether x is equal to y or it's not equal to y, it really doesn't matter. So from this, the first conclusion that we have, we can't effectively conclude whether x is equal to y or not. Okay, so now from second and third conclusion, like second conclusion does say x is equal to y, the third one also says x is equal to y. But the problem is again the first conclusion, right? So it may happen that x is equal to y, it may happen that x is not equal to y, both the things can happen. So do I have a conclusive answer from statement 1? The answer is no, I don't have any conclusive answer. Okay, so if I do D, A, B, C, E, so D goes out, A goes out. Okay, let's look at the second one. Second one says that p square x is equal to p square y. Now again, I won't cancel p square on both the sides because p square can be 0 when p is equal to 0. So I'll write p square x minus p square y is equal to 0. So it will be p square into x minus y is equal to 0. So again, you can have p square equal to 0, which will give us p is equal to 0. I can have x minus y is equal to 0, which means x is equal to y, or at the same point of time I can have p is equal to 0 and x is equal to y. All the three can happen. Now these three conclusions will behave exactly the same way as the conclusions of the first statement. That is, when p is equal to 0, then x may or may not be equal to y. But the other two conclusions are saying that x is equal to y. So we do not know which condition will satisfy. Right. That means B also goes out. Now, when I'll combine both these statements, interestingly, all the three statements are coming out to be common. All the three statements are coming out to be common. So, do we have a conclusive answer if we combine both these statements? No, we don't have a conclusive answer, which means C also goes out, and hence our answer is option number E. Okay. All right, let's move on to the third one. Pause the video and draw this question, please. Okay. Is X greater than Y? So my first statement is AX greater than AY. So again, I won't cancel A on both the sides because I do not know whether A is positive, negative, or zero, right? If A is positive, then I can cancel. My sign of inequality will not change. If A is negative, I can still cancel, and in that case, my sign of inequality will change. But if A is equal to zero, then I can't divide both sides by zero, right? We know that. Which means I will again subtract AY on both the sides. So this will become AX minus AY is greater than 0. So that is AX minus Y is greater than 0. So this is A into X minus Y greater than 0. It's like product of two numbers which is greater than 0, or product of two things which is greater than 0. So first conclusion is both positive, and second conclusion is both negative. So if X minus Y is greater than 0, this will give me the conclusion that X is greater than Y. But if X minus Y is less than 0, this will give me the conclusion that X is less than Y. Now it's not given to me. It's not given to me in the question whether A is positive or negative. So we'll have to take both the cases into consideration, right? So do I have a conclusive answer from statement 1? No, I don't have a conclusive answer from statement 1, which means A goes out, D goes out. Okay, now the second one. Second one is A square X is greater than A square Y. So again, I won't remove A square from both the sides because again, I do not know whether A square is 0 or positive. Now A square can't be negative, that's for sure, but A square can be 0. A square can be 0. So again, I can't just remove or divide both sides by A square. So I'm going to subtract A square Y on both the sides. Let's take A square common. Into X minus Y is greater than 0. Now, let's first understand the role of A square here. A square is a square, right? Now, square quantity can be 0 or it can be positive. Square quantity can be 0 or it can be positive. Now, if A square is 0, then the entire expression, which is A square into X minus Y, will also become 0. If A square is 0, then the entire expression A square into X minus Y will automatically become 0. Because anything multiplied by 0 will automatically give you 0. So if A square is 0, then A square into X minus Y will automatically become how much? It will simply become 0. Now that will contradict the fact given to us. Because it is given to us that A square into X minus Y is greater than 0. So if I take A square to be 0, then this fact will be contradicted, right? So I can't take A square to be 0. This is not possible. It's not feasible. So the only option that I have as far as A square is concerned is that A square has to be positive. A square has to be positive. So A square is positive, which means a positive number is multiplied by X minus Y and the result is also positive. A positive number is multiplied by X minus Y and the result is also positive, which means X minus Y can only be positive. Which means X minus Y can only be positive. X minus Y cannot be 0 because positive multiplied by 0 will give me 0. That's not feasible. And X minus Y cannot be negative because when a positive number is multiplied by a negative number, then the result becomes negative. That will also contradict the fact. So the only possibility that X minus Y can carry, the only possibility that X minus Y can carry is that x minus y has to be greater than 0, which means x has to be greater than y. This is the only possibility that we have. So from statement 2 alone, I am getting the conclusion that x is greater than y. I am getting the conclusion that x is greater than y because a square can only be positive. And I want the product of two numbers to be positive, and one of them is definitely positive, so the other has to be positive. I don't have any other option, which means my answer in this case becomes B. I don't have to move on to C or E. It's not required. Okay. All right, let's move on to the question 4. Pause the video and try this question, please. Give this one a try. Okay, let's see what we can do with this one. It says that is A greater than B? Is A greater than B? First statement that we have is A by B is equal to 8 by 7. So A by B is equal to 8 by 7. This represents a ratio that when A is equal to 8, B will be 7. So I can say A can be equal to 8k and B can be equal to 7k. What is k? K is a ratio constant. What is k? K is a ratio constant. Now ratio constant can be positive. Ratio constant can be negative. Like k can carry values such as 1, 2, 3, 4. At the same point of time, k can also carry values such as minus 1, minus 2, minus 3, minus 4. So if k is positive, then 8k will automatically be greater than 7k. Let me give you certain examples. K is 1, so I will have values like 8 and 7. K is 2, we will have values like 16 and 14. K is 3, we will have values like 24 and 21 and so on and so forth. So whenever k is positive, in that case 8k will automatically be greater than 7k. Right? There is no second thought in this. But what if k is negative? In that case 8k will automatically become less than 7k. In that case 8k will automatically become less than 7k. Like for example, if I take k to be minus 1, then the values will be minus 8 and minus 7. Which of them is greater? Minus 7 is greater. Smaller the number in negative, effectively the greater it is, right? If I take k to be minus 2, then it becomes minus 16 and minus 14. If I take it to be minus 3, then it becomes minus 24 and minus 21. So that actually depends upon the value of k. Just by saying that a by b is equal to 8 by 7 does not stand for the fact that a is greater than b. Neither it stands for the fact that a is less than b. So do I have a conclusive answer from here? No, I don't have any conclusive answer from here. So if I write D, A, B, C and E, A goes out, D goes out. A goes out, D goes out. Okay. Let's talk about the second one. The second statement, that is A square is greater than B square. Okay. Now, one way to understand this, if A square is greater than B square, then that means that mod of A will be greater than mod of B. This is the conclusion of this. If A square is greater than B square, then that means mod of A is greater than mod of B. Which means if A is equal to 3, then we can say that B can be equal to 2. B can be equal to minus 2, right? B can be equal to 1. B can also be equal to minus 1. And there are like other couple of values also. I'm just taking the integer values into consideration. Similarly, if I take A to be minus 3, then also these values are applicable. Because it's the mod of A which happens to be greater than mod of B. It's mod of A which happens to be greater than mod of B. Now in the first case, when I took A to be 3, then all these values of B will automatically be less than the value of A. You can take any value. For example, you can think of 2.9 minus 2.9, right? But you will never go to 3 or minus 3. That's not possible because mod of a is less than or greater than mod of b. So think of any value from greater than minus 3 to 3. Think of any value. You can basically say that the value of b will be anything from minus 3 to 3. Think of any value. All these values of b will effectively smaller than the value of a. It has to be because a is 3. So in case 1, when a is positive, you take any value of b satisfying the inequality, a will always be bigger. A will always be bigger. Whereas in the second case, when we took a to be minus 3, because we have to satisfy that inequality, right? Our actual goal is to satisfy this inequality. That mod of a should be greater than mod of b, right? If I took a to be minus 3, because mod of minus 3 is what? Mod of minus 3 is also 3. In that case, b will again be between minus 3 and 3. When I took a to be minus 3, when I'll take a to be minus 3, ensuring that the inequality is met, ensuring that the inequality mod of a is greater than mod of b is met. If I take a to be minus 3, I'm going to take this, I can only take the same values of b as I took in case 1 when a was 3. So again, the value of b will be between minus 3 and 3. But now in this case, all the values of b, in this case, all the values of b will be greater than value of a. It will be greater than value of a. So do I have a conclusive answer? No. I again don't have a conclusive answer. Simply saying that mod of A is greater than mod of B does not stand for the fact that A will be greater than B. It can be the other way around also. So does statement 2 alone sufficient to answer the question? No, it's not. It's not possible. So what if we combine them? So if we combine them, so I think we're gonna again have both the cases when it can be positive and it can be negative, right? A can be negative, B can be positive, A can be negative, B can be negative. Like we will have both the cases again. So again, do we have a conclusive answer from here? Right? Again, we don't have any conclusive answer, right? So again, C also goes out. So E is simply our answer. E is simply our answer. Okay. All right. This was bit difficult, but anyways, you should have. These are like easy level questions, like 600, 650 level questions. Okay, these are like doable ones. You should be able to do this. But anyways, if you're doing inequalities with data sufficiency for the first time, then I do understand you will face difficulties. It's not an uh, it's not an easy thing to do. Okay. All right. Let's move on to question number 5. Pause the video and try this question, please. All right. So is Z an odd integer? This is the question. Is Z an odd integer? Statement number 1. 7Z is an odd integer. 7Z is an odd integer. Now 7Z basically means 7 into Z is an odd integer. So I know that when you do odd multiplied by odd, that is the only case when you get result to be odd. When you do odd multiplied by odd, that is the only case when you get result to be odd. So 7 is odd. We do not know what Z will be, and the result is an odd integer. So in that case, I can say that Z has to be an odd integer. I can say that Z has to be an odd integer. Because if you multiply 7 with an even number, let's suppose you multiply 7 with 2 or 4 or minus 2 or minus 4. In all the 4 cases, you'll get result to be even. So if you multiply 7 with Z and the result is odd, then Z has to be an odd integer. But here is a catch in the question. See, we need to understand this. When you say 7z is an odd integer, that means 7 multiplied by z is an odd integer. So one of the cases is z is an odd integer. But what if z is a fraction? What if I take z to be a value like 1 by 7 or 3 by 7 or 5 by 7, 9 by 7, 11 by 7? If I multiply if I multiply any of these fractions, if I multiply any of these fractions with 7, the result will still be an odd integer. The result will still be an odd integer. Like 7 into 1 by 7 is 1. 7 into 3 by 7 is 3. 7 into 5 by 7 is 5. 7 into 9 by 7 is 9. These are all odd integers. So if 7z is an odd integer, if 7 into z is an odd integer, it does not stand for the fact that z will be an integer. That's the first thing we need to understand. If 7 into z is an odd integer, then it does not even stand for the fact that z will be an integer. Z can be a fraction also, because I want 7 into z to be an odd. Let's multiply it with a fraction. Let's multiply 7 with a fraction whose denominator is 7. So 7 and 7 will cancel out, right? So again we have two cases. Z can be an odd integer, but z can be a fraction also, which means statement A is not sufficient to answer our question. A goes out, D goes out. A goes out, D goes out. Okay, second one. Second statement says that z divided by 5 is an odd integer, which means I can say z will be 5 into an odd integer. Now, in this case, on the right hand side, it's given to me that this is an odd integer. This is given to me. This is given. So when you will multiply 5 with any odd integer, when you will multiply 5 with any odd integer, I can simply say that this entire result will always be an odd integer. I can simply say that this entire result will automatically be an odd integer. Odd into odd is always odd. Now I don't have any scope of fractions, right? Because it's already given to me that the right hand side is an integer. So 5 is also an integer. RHS is also an integer. So integer into integer has to be an integer. There is no second possibility. So odd integer into odd integer will automatically become an odd integer. Okay, which means B alone is sufficient. Hence your answer is option number. Hence your answer is option number. That's it. All right, pause the video and draw this question, please. All right, let's see what we can do with this one. So p square divided by r is greater than 0. Okay, this is what has been asked to us. Now let's just understand a couple of things before we actually move on to the statements. If we talk about p square, it's a squared number, right? So p square can either be positive or it can either be 0. First of all, p square can't be negative. This is something we need to understand, because it's a squared quantity, so it can either be positive or it can be 0. Second is, if we talk about r, then r can be 0, r can be positive, and r can be negative also, right? All the three things are possible. Now we just have to look at the two statements, and we actually need to figure out the signs for both p square and r. Like one of them will not do. Like if, let's suppose, if p square is positive, then r can be positive as well as negative, right? So I basically need the signs for both of them. I need the signs for both of them. So looking at these statements 1 and 2, I can ensure one thing. Since it's asking me whether p square by r is greater than 0, looking at the two statements, one of the statement give us information only regarding p, whereas the other statement give us information only regarding r. right? So I don't think any one of them will actually give us a conclusive answer if looked at individually, right? Because the first one simply says that p can be negative, p can be positive, p can be zero. So like p square can be anything. So p square can be zero, p square can be positive. Effectively, it will not be negative, but it can be zero, it can be positive also. But I don't know the value of r. I need the value of r. Similarly, looking at the statement 2 individually, r is negative, r is zero, r is positive. But I don't know the value, I don't know the sign of p square. So again, I can't make up any conclusive answer looking at statement number 2. Also, if I draw out all the possibilities as far as the signs are concerned for p square by r, I can have positive divided by 0, I can have positive divided by positive, I can have positive divided by negative, and I can have 0 by 0, I can have 0 by positive, and I can have 0 by negative. So these two are effectively not defined. These two are effectively not defined in maths. This will give me a positive result, this will give me a negative result, and these two are going to give me like zero result. So is p square by r greater than 0? So it can be greater than 0. It can be greater than 0 when they both are positive, or it can be 0 or negative when these three cases are applicable, right? So I can have both the answers effectively. So if we look at the statements individually, if I look at the statements individually, I don't think I'll be able to answer the questions. So if I do D, A, B, C, and D, I can simply say, okay, A, B, and D will simply go out because individually I won't be able to solve it. The only possibility is if I combine them, that's it. Nothing else. Now, when I combine them, when I combine them, if I talk about p square can be 0, p square can also be positive. Both of them are applicable. Similarly, if I talk about r can be positive, r can be negative, and r can be 0 also. Even if I don't take the 0 part into consideration, even if I don't take the 0 part for r into consideration, let's suppose I only take the positive and the negative part into consideration, and I'll only take the positive part for p square into consideration. I'm not even taking the 0 for p square also into consideration. So I can have both the possibilities. I can have positive by positive. I can also have positive by negative. So positive by positive will be greater than 0, but positive by negative will be less than 0. So again, do I have a conclusive answer? No, I don't have a conclusive answer. So C also goes out and my answer simply becomes option number. See, it's just an observation. How do you interpret a question, right? You don't always have to be like, okay, this is statement one, this is statement two. Let me just try and solve them for all the possible cases. No, read the question carefully. First, understand what the question is asking you. Figure out the cases. Okay, this all can happen, and then move to the statements, right? Okay, okay. Pause the video and try this question number 7, please. Okay, let's see what we can do with this one. Is a square by b less than 0? A square by b less than 0. Now, it's exactly like the previous one. The only thing which has changed is in this question they're asking for less than 0. If I talk about a square can be 0, a square can be positive, it can't be negative, that's for sure. But if I again talk about b can be 0, b can be positive, b can be negative also. Now I want result to be negative, which means one of them has to be negative. One of them, that is a square or b, one of them has to be negative. Either it should be a square, which has to be negative, or it has to be b, which has to be negative. Because I want result to be negative. Okay. Now a square can't be negative. A square can't be negative because a square can be 0 or positive. So the interesting part about this question is not actually about a square. This question is not actually about a square because a square will have no role to play. A square has a defined position. I will either be 0 or I will either be positive. I can't be negative. So the actual question is like, is B negative? Because a square can't be negative, which means the only possibility for this fraction to be negative is when B is negative. So is B negative? Now that answer I'm not going to get from statement number 1, that's for sure, because statement number 1 is all about A. So if I do D, A, B, C, E, I know A is out and I know D is also out. Which brings me to statement number 2, which gives me that B is between 2 and 4. Now if B is between 2 and 4, I can conclusively say that. B will be positive. I can conclusively say that B will be positive. So if I use statement number 2, I can say that my fraction is A square divided by positive. Now again, A square can be 0, A square can be positive, which gives us two conclusions. One is my fraction is 0 by positive, which is 0. Another is my fraction is positive by positive, which is positive. Which means A square by B, which means A square by B only using statement 2. Only using statement 2, I can say that A square by B is greater than or equal to 0. Only using statement 2, I can say that A square by B will be greater than or equal to 0. So is A square by B less than 0? The actual question is A square by B less than 0? So our conclusive answer is no. If I use statement 2, then A square by B is positive or 0, but it's never negative. It's positive or 0, but it is never negative. Which means from statement 2, I'm getting the conclusive answer, which means my answer is simple. Again, understanding the question is paramount. Right? That's the key part. Alright, pause the video and draw this question number 8, please. Alright, let's see what we can do with this one. So is G greater than H? This is the question. Statement number 1, G minus 5 is greater than H minus 5. I think this statement is quite doable. You can simply add 5 on both the sides. So you will get G minus 5 plus 5 is greater than H minus 5 plus 5. So you'll simply get G is greater than H. I think that was pretty simple. So from statement 1, you are definitely getting the answer, which means B goes out, C goes out, and E goes out. You will only have two options. Either A or both the statements individually are sufficient. Now, second statement says that G square is greater than G into H. Again, don't make the mistake of cancelling one G's on both the sides, right? We have discussed this in the starting of the video itself, that don't cancel, right? It's not like cancelling, it's more like dividing, right? So bring GH or subtract GH on both the sides. So you should be getting this. So G into G minus H is greater than 0. Product of 2 is greater than 0, which means both positive or both negative. So if both are positive, then G greater than 0. G minus H greater than 0, which means G is greater than H. This is conclusion number 1. Or both negative, which means G less than 0. G minus H less than 0, which means G is less than H. So do I have a conclusive answer from statement 2? No. I can have G greater than H, but I can also have G less than H. So D will not be my answer. So statement 1 alone is the only sufficient thing that are required. So A is my answer. That's it. Okay. Pause the video and draw this one, please. Okay, let's see what we can do with this one. Is x equal to y? Statement number one, x square is equal to xy. So I'm going to subtract xy on both the sides. So x into x minus y is equal to 0. So I can have x is equal to 0. I can have x is equal to y, or I can have x is equal to 0 and x is equal to y. So if I talk about the first condition when x is equal to 0, in that case x may or may not be equal to y, right? Because if you have 0 on both the sides, then you can take y to be 1, 2, 3, 4, 5, 6, 7, 8. You can take it to be 0 also, no denying on that part, but that's not like a necessary condition. So if x is equal to 0, then x may or may not be equal to y. You do not know that. But for the other two cases, you are getting x is equal to y. So it may happen that x is equal to y, it may happen that x and y are not equal. So simply by saying that x square is equal to xy, we will not have a conclusive result whether x is equal to y or not. It may be, it may not be, which means statement 1 is definitely not sufficient. A goes out, D goes out. Second one, x square is equal to y square. We know the conclusion for this, that is mod x is equal to mod y. Or let's suppose you do not know this, let's solve this out, no problem. Subtract y square on both the sides, so x square minus y square is 0. So x plus y into x minus y is equal to 0. So we can have x is equal to minus y, we can have x is equal to plus y, right? So if x is equal to y, then yes, x is equal to y. But if x is equal to minus y, then no, x is not equal to minus y. Again, do we have a conclusive answer from here? No, we don't have any conclusive answer, which means B also goes out. But what if we combine them? What if we combine them? If we combine them, then I think the only common part that we have is x is equal to y. That is x is equal to y. I can't take x is equal to minus y, because even if I take x is equal to minus y, then the common part with x is equal to minus y will probably be in this condition. But if x is equal to 0, then minus y is 0, which will again give me y is equal to 0, right? So that doesn't add up to anything. So the common part that I have is simply x is equal to y. That I have is simply x is equal to y. So when I'll combine them, then do I have a conclusive answer? Yes, I do have a conclusive answer, which means my answer simply becomes option number C. My answer simply becomes option number C. Okay, let's try another one. Pause the video and try this question, please. I think there is one mistake in this question. This should be a to the power b, which is equal to 1. This is not a into b, this is like a to the power b. Try the question now. All right, let's try this question now. The first one will give us this like an interesting question. This will I'll be explaining you a concept also in this, so please do pay attention. So let's talk about statement number one. The question is simple: is a into b greater than 1? So statement one is a to the power b is equal to 1. Now this is an important identity in exponents when you have a to the power b is equal to 1. This has three conclusions. Conclusion number one: if a is equal to 1, then b can be any real number. 1 to the power anything will always give you 1, irrespective of anything. Second is, if b is equal to 0, then a can be any real number but 0. any number to the power 0 is always equal to 1 apart from 0, because in math 0 to the power 0 is not defined. Third, if a is equal to -1, in that case b has to be even. In that case b has to be even. Please learn the three conditions. This is very important when you talk about a to the power b is equal to 1. So I think you would have realized by this now by now that you won't be able to give any conclusive answer regarding a into b greater than 1, right? So if a is 1, b can be any real number, b can be 2, 3, 4, 5, it can be -2, -3, -4, -5. So if I just talk about conclusion number 1, I can have a into b greater than 1. I can also have a into b less than 1. I can actually also have a into b equal to 1. So do I have a conclusive answer? No, I don't have any conclusive answer. So if I talk about D, A, B, C, E, A goes out, D goes out. Okay, now the second one. Second one simply says that B is equal to -1. It does not give me any information regarding A. So what if A is like -2, -3, -4, and so on and so forth? In that case, A into B will be greater than 1. But what if A is equal to 2, 3, 4, and so on and so forth? In that case, A into B will be less than 1 also. What if A is equal to -1? In that case, A into B will be equal to 1 also. So do I have a conclusive answer? No, I don't have any conclusive answer. Now the only option is to combine the two things. So from statement 2, I have B is equal to -1. So I think that will satisfy with first part. I can have b is equal to -1 here. It won't satisfy with this one, second one, because b is 0. It won't satisfy with the third one because b has to be even. So when I'll combine the two, in that case b is -1 and a is 1. So product AB will automatically be -1. So if AB is -1, then is -1 greater than 1? The conclusive answer is no. The conclusive answer is no. So do I have a conclusive answer using both these statements? Yes, we do have a conclusive answer. And the answer is C. And the answer is C. Okay, so these are like the very basic questions from inequality. If you know what the basics of inequality is all about, right? If you know the basic concepts, then these are the questions that you should be practicing first, right? So I think these questions are more than sufficient to give you a good amount of understanding of what basic inequality questions look like, right? All right. So I think we can do a couple of more. So yeah, let's try this one also. So pause the video and try this one also. Okay, let's see what we can do with this one. So it's simply asking us, is n less than 0? Simply asking us, is n less than 0? That means is n negative. First statement says that m is less than n. Okay. Now if m is less than n, then there are like a lot of possibilities. M less than n basically means that on the number line, n will be on the right and m will be on the left. It may happen that this is positive, this can be positive, this can be 0, this can be negative. It may also happen that n is 0 and m in that case is negative. It may also happen that n is negative and m is also negative. Like a lot of possibilities which can happen, right? There are actually like a lot of possibilities which can happen. So do I have any conclusive answer from this? No, I don't have any conclusive answer from this. N can be positive and can be 0 and can be negative also. So if we talk about D, A, B, C, E, A goes out and D goes out. Okay. What about the second statement? Second statement says that minus of n is less than m. So I'll basically have m on the right and minus n on the left. So I can have m as positive. In that case, minus n can actually become 0 if n is 0. Minus n can become negative when n is positive. Minus n can also become positive when n is negative. Right? For example, you can have m as 3. I can take n to be 0. I can take n to be 2 and I can take n to be minus 2 also. All the three conditions still satisfy. Okay. So you can also go for like m to be 0. In that case, minus of n will be negative. In that case, n has to be positive. Right? And you will have one more condition. But basically, I have realized by this time now that statement 2 alone will not give me whether n is negative or not. So B also goes out. But now what if I combine both these statements? What if I combine both these statements? First statement says that m is less than n. Second statement says that m is greater than minus n. So if I represent the three things on the number line, I will have n here, I will have m here, and I will have minus of n. Okay, now if n becomes positive, then this will automatically become negative. That's for sure. And if we talk about m, this m can be positive, this m can be 0, this m can be negative. But anyways, we are not concerned with m, we are actually concerned with n. What if n is negative? What if n is negative? If this becomes negative, then this becomes positive, and that's not possible. That's not possible because on a number line, any number lying to the right is always greater than any number lying to its left. Any number lying to the right is always greater than any number lying to its left. So this case where n is negative and minus n becomes positive, it's not feasible. It cannot happen. N can't be negative. N lies to the right of minus n because n is greater than m, right? So this case is not applicable, and also n can't be 0 also. N can't be 0 because if n is 0, then minus n, m and n will again, they all will lie on the same point, and that's not feasible, right? Okay, so the only possibility is that n is positive. So this is positive. So is positive less than 0? My conclusive answer is no. My conclusive answer is no. Which means my answer to this question simply becomes option number C. That both statements combined are sufficient enough to answer the question. Alright. We'll take one more question for this video. So pause the video and try this question, please. All right. So let's see what we can do with this one. It says that A is equal to B plus C. Is A greater than B? This is given to us that A is basically sum of two numbers, and is A greater than B? Okay. Now first one says that B is greater than 0. That is B is positive. So A is actually equal to a positive number plus C. Now what about C? Do we know anything about C? Like, like C can be positive, C can be 0, and C can be negative also. If C is positive, then A will automatically be greater than B, right? Because A is B plus C. So if I'm adding a positive number to B, then A will automatically become greater than B. Like A is B plus C. This is positive. This is also positive. So I'm like adding two positive numbers. So the result has to be greater than B. It has to be, right? But if C is 0, then A will simply be equal to B. If this is positive, this is 0, then A will simply be equal to B. And if C is negative, in that case, A will be less than B because you are subtracting something from a positive number, right? So unless and until I know the value of C, I can't deduce anything. I can't say anything for sure. So if I do D, A, B, C, E, A goes out, D goes out. Because just by knowing B is positive, I can't say anything because C can be positive, negative, 0. It can be any of the three things. And I do not know what it's going to be actually. Second case is when C is positive, which means A is B plus a positive number. A is B plus a positive number. Now, if A is B plus a positive number, and if I were to represent this situation on a number line, can I say that if B lies somewhere here, then B plus positive have to be always on the right of B? B plus positive will always be on the right of B. Can I say that for sure? Because I'm adding something. Irrespective of whether B is positive, negative or 0, if I'm adding a positive quantity, my value will always increase. Let's say suppose B is minus 2. If I'm adding a positive number to minus 2, the value will increase. It has to. What if B is 0? Then also 0 plus positive is again positive. My value is still increasing. What if B is positive? Then positive, I'm adding a positive number to a positive. My overall result will still be greater. Right? So if I keep B here, then B plus positive has to be on the right of B. It has to be. So even if I don't know the value of B, if C is positive, and if I don't know the value of B, I can still say that A will be greater than B. Or let's suppose you're still not fine with it. No problem. You know that A is equal to B plus C, right? This is given to you. C is positive. So A is equal to B plus C. C is positive. So if I subtract B on both the sides, then A minus B is still C. A minus B is still C. Now, if this is positive, then can I say the left hand side also has to be positive? If C is positive, then the LHS also has to be positive, right? Which means A minus B will be greater than 0, which means A is greater than. So statement B alone is definitely going to give me the answer. That will definitely give me the answer. Alright, so these were like some basic questions which on inequalities with data sufficiency which you needed to know so that you can actually start your preparations with inequalities. These are like just the very basic level questions, right? Inequalities plus modulus goes a very long way, right? So if you're new to this chapter, start with the basics. So you can go to the playlist on Benji's Education, SAT plus GMAT plus GRE. Go through the linear inequalities, understand what are linear inequalities, go through the quadratic inequalities, understand the basics of those things, and then you can like again go come back and look at these questions so that you have a very good understanding of how to solve inequalities questions. Once you're done with this, then I have also uploaded the 700 to 800 level GMAT questions on inequalities. Go through those videos also, right? That will actually help you a lot as far as your preparation is concerned, right? So thank you so much guys. Keep watching and keep learning. If you have any doubts, if you have any queries, if you have any questions, you're more than welcome to ask me. You can mail me, you can WhatsApp me, you can also drop in a comment on YouTube itself. And if you haven't subscribed the channel, please do that for more videos and exam related content. If you need any specific video on any specific topic, please feel free to ask me, right? Alright then guys, thank you so much. Keep watching and keep learning. Thank you.